Picture this. It's a gorgeous day. The sun is shining and you're relaxing under a tree, enjoying a good book, when suddenly an apple falls and hits you on the head.
They say it went a little something like this for Sir Isaac Newton, but that's not the only thing that came crashing down. Newton realised that the apple's fall was due to gravity, one of the most fundamental forces in the universe.
From here, he deduced that 3 laws of motion that are the fundamental principles of physics. These laws describe how objects move and interact with each other.
You experience these laws all the time, whether you're playing sports, dancing, or even reading a book. But how would you be ruled by these laws of motion in outer space? The Earth's gravity is keeping us on the ground, but the farther you move away from Earth, the smaller its gravitational pull is. Take, for example, the International Space Station, located in the space around Earth. The ISS is not far away enough to be completely free of Earth's gravitational pull. Instead, it's in a state of constant freefall, which creates an environment of weightlessness, or microgravity. How do Newton's laws of motion hold up here? Let's find out. We're going to play around with Newton's laws of motions on Earth and in space, with ESA astronaut Samantha Cristoforetti. Newton's first law states that a body at rest will remain at rest, and a body in motion will remain in motion unless an external force acts on it. Check out this ball on the ground. It's not moving at all. That's because all the forces acting on it are balanced. But as soon as Nina kicks the ball, she applies an external force and the ball starts moving.
And it won't stop moving until another force applied by Ali's foot stops it. We can also change the direction of motion by applying another force from another direction. Watch this.
See how the ball moves in the direction of the first force applied, and then changes direction once the second force is applied? The final direction of motion is a result of both forces acting on it.
That's here on Earth, but what about in space?
Astronaut Samantha Cristoforetti is holding a ball that appears to not be moving. As soon as she applies some force to it with a pump, the ball starts moving in the direction of the force. According to Newton's first law, it will keep moving in that same direction until another force is applied.
A cool way to see this law in action is during a reboost of the International Space Station.
As the ISS orbits the Earth at around 400 kilometers altitude, our atmosphere causes the ISS to lose about 100 meters of altitude per day. That means it needs periodic boosts to maintain its orbit. And to do that, a cargo ship attached to the back of the ISS fires its engines for a few seconds to put the space station in its proper orbit. During the reboost, Samantha and her friend Paxi do not experience the same increase in acceleration as the ISS, because the force of the reboost is only applied to the structure of the space station and not to them.
And even though it looks like they're moving towards the camera, it's actually the ISS that's moving around them.
Seems crazy, but it's actually just physics. So that's Newton's first law of motion, the foundations of how objects behave at rest and in motion. And with space travel, it's even more fascinating.